Alright kids, let's take a look at question number 9. Most people did pretty good on this one here. If you found the pattern. It's always like I say with chemistry, it doesn't make sense until it makes sense. And then once it makes sense, it makes perfect sense. At any rate, so we have a ratio of, we have some data here that tells you the mass of a sample, the mass of carbon, and the mass of hydrogen. And the question is, a colorless liquid is thought to be a pure compound. Analysis of the 3 samples of the material yield the following results. So if it's a pure compound, it'll always have the same ratio of elements. So like H2O will always have 2 H's to 1 oxygen. And if we have the masses, the ratio of the masses of carbon to hydrogen should be the same if it's a pure compound. If not, it could be a mixture. You could have 10 carbons and 1 hydrogen or 2 carbons and 1 hydrogen. But if it's a compound, a pure compound, then it's going to have the same ratio. And this actually, I believe this is CH4. So the ratio of carbon and hydrogen should be the same. But you don't know that just yet. But let's see. So this person knew that trick, and they have the ratios of A, B, and C, and they have the grams of carbon to the grams of hydrogen for each one. And they found that they're about the same. So if the ratios of the carbon to hydrogen are about the same, then it's a compound, it's a pure compound. And I picked this particular one because this explanation I thought was pretty clear. The material is a pure compound because the ratio for each sample, when compared to the next, are the same. The ratios of this are the same, and therefore, so this is nice. You have data, and then now you explain what that means. They have the same composition, results throughout, and therefore it is a pure compound. Because that is what a pure compound is. It's a bunch of atoms that are stuck together in the same ratio, like H2O. So there you go. Hopefully this helps.